This is Genesis, and it's a bit like a universe simulation, but with God mode, where we build, break it down, and redo it better. And hold on to your papers right now, fellow scholars, because we've done nearly 1,000 videos over 10 years, and you will see some of the most beautiful simulations you ever saw here. This is Genesis, a universal physics engine available for all of you for free. You see, there are so many kinds of different physics simulation systems out there, and each of them can do one little thing extremely well. Soft bodies, fluids, granular simulations, particles, honey, light simulations, one kind of experiment, one system. If you want something else, you have to implement a different algorithm. However, not here. Genesis puts all of these together into one unified system, and it took my breath away. Not just because, look at this incredible beauty, but there is more here. One I also really like about this work, that it explains itself. Genesis is a physical platform designed for general-purpose robotics, embodied AI, physical AI applications. And in a moment, I'll tell you how this system might change the world around us as we know it. This technique might even cook your dinner soon and fold your laundry. Okay, so how? Well, step number 1. Let's generate realistic simulations quickly. How quickly? Can it be faster than MuJoCo, the library that DeepMind bought for a fortune? Well, NVIDIA's Isaac Gym is much faster than that. It cannot possibly be that, right? Excuse me, what? Are you seeing what I am seeing? It is up to 80 times faster, and its speed is in the what? Hundreds of millions of frames per second. Is this really true? And what in the paper is that good for? Yes, it is true, but for a highly optimized benchmark case, of course, not in all cases by far. I'd like to emphasize that, but still, wow! Here is a thought experiment to demonstrate its potential. At 244 million frames per second, it can simulate so fast that it goes from the birth of Jesus Christ up to today 4 times over, and for every single hour of your life it can study for 30,000 hours of in-game time. Of course, it does not simulate the whole world, but it can generate 30,000 different worlds in parallel. And now we are ready for step number 2. What is that? Dear fellow scholars, this is 2-minute papers with Dr. Kara Jonaifahir. Step 2. Let's not just look at these little worlds, but also put a little robot in them to study them. Here is DeepMind's Soccer AI system that started from zero, and then 3 years later it could do this. 3 in-game years later, of course, in our time is just a few hours. These little AIs started out like this, and when they studied for 10 years, they ended up here. So now, imagine these little robots studying for 30,000 years for every hour of our lives. Or even better, let them study in 30,000 different worlds, 1 hour each. Imagine this many different kinds of warehouses, kitchens to work in, sandy beaches to walk on. And by the time we upload the AI into a real robot, it will be incredibly helpful. This is what we call Sim2Real. I can't even imagine how capable it will be, because 3 and 10 years were amazing. What could 30,000 years of learning look like? What a time to be alive. And that is why this work might change the world around us as we know it, teaching real robots to perform useful tasks around us. And in the simulation, we can have different kinds of robot morphologies and have them learn how to be a good robot, including a robot that looks like a hand, or this cute, soft robot that worms its way into this episode. Or of course, the super cute Disney robot that steals everyone's hearts. And then, when they proved that they are useful and safe, only then can they go out there in the real world. Now, we're not done yet. Genesis has more goodies. It can generate character animation too. These look absolutely incredible. Wow! It can generate interactive worlds too, and objects separately within these worlds. It is also a generative data engine that can generate new things from a simple text prompt. I can't wait to fire up the GPU instance in Lambda and give it a try, especially because, get this, it is designed to be differentiable. Oh my! So, what does that mean? What a differentiable programming system does for us is that we can specify an end state, which is the blue ball on the black dot, and it is able to compute the required forces and angles to make this happen. You can kind of create desired futures with it. We talked about this 500 papers ago. Yes, you can hear about pretty much everything on 2-minute papers. The user guide, code, library, everything is available for you for free in the description. Now, it is very difficult to get YouTube to recommend this kind of content. However, we tried it before and found that if I can get you to leave a kind comment, it really helps. So I would like to ask every single one of you to press like and leave a kind comment so we can make videos about more beautiful works like this. That would be so cool. Now, just to highlight both the good and bad, we don't shy away from that around here. So, 2 things. 1. Not every case is as good as benchmark cases, so real-world performance will be less, depending on what we do. The 244 million frames per second was the Thon experiment with plenty of disclaimers. That is always important to highlight. Also, there is some criticism online about the claims in this work, and there is a detailed answer to the criticism as well. These are super useful reads, both available in the video description. Here you see me running the full DeepSeek AI model through Lambda GPU Cloud, 671 billion parameters, running super fast and super reliably. This is insane. I love it, and I use it on a regular basis. Lambda provides you with powerful NVIDIA GPUs to run your own chatbots and experiments. Seriously, try it out now at lambda.ai/papers or click the link in the description.